Okay, so let's continue with the next video, which is now finally the regression analysis. I mean, if you check the quant lecture, that is the last thing that we are going to do to test the hypothesis. Now we will be ready to support or reject. So do like I do. First go to analyze, then go to regression, and then go to linear, right? Click there. And now what you have to do is to put here in dependent your dependent variable. So go to hub. I will continue with example like if I am group 1 or group 2. So hub here. Please make sure that you have the hub that we calculated, the average, or the variable that we calculated, not the hub 1 and all that. You can forget about those. You can just go straight and use the hub that we calculated. And then for this model, we're going to use only the dependent variable, only financial stress, only one. And then click options. No, sorry, options, no. Statistics, click statistics, and then click collinearity diagnostic. We need to click that and then continue. And then click OK. Make sure your dependent variable, if you have global mindset and professional aspirations, GSM and Pro, whatever you have, you're dependent and you're independent, and then click OK. And then you will get these numbers. And maybe you are a bit familiar with that because in the lecture I told you how to interpret this. So let's take a look. First thing that we need to check the significance of the model. 0.001. That's good. We can move forward. The model is significant. That's the first thing we need to check. Okay, we move forward. What happens if this model fit doesn't work? If your p-value is more than 0.001, if this is 0.2, for example, or 0.5, you stop. You cannot do anything with this model, you go to the next model, right? But luckily with group 1, we don't have that issue. We can move to the next point. Which is the next test that we need to do? Which is the next thing that we need to check? The R-square. We have a quite low R-square, adjusted R-square here, 0.047. So 4.7% of the variance is explained by our model, but it's okay. We only have one variable. That's the important thing about having control variables. Right now, we don't have any control variables. So we have a very weak model, but I mean, it's okay. We can move forward. It's just, I mean, 0.05, it's very low, but we can move forward just for this exercise. I guess if you get also something very low in your models, I mean, just for this pedagogical exercise, let's move forward. Let's say that it's okay. We recognize it's low because we only have one variable. What will we expect? The next thing to check is the multicollinearity, which is the BIF value. Make sure they don't have anything above 4, because if you have more than 4, that can be problematic. But no, we don't have any issues with BIF because it's only one variable. So it's impossible to have multicollinearity. We don't have more than one variable, so we cannot have that, right? So that's the third test that we will do. So significance, model fit, R-square, multicollinearity. The last thing to do is the significance of our independent variable and the sign. So the significance is less than 0.001. That's great. That means that we have 99.99% of significance. And it's always 1 minus this to calculate the percentage of confidence that you say that is significant. You are confident at 99.99% that the relationship is significant. That's how you interpret it. And then the other thing that is important to check is the sign. The sign is negative, and as I understand in group 1, the hypothesis is that more financial stress will lead to less happiness. So the sign is coherent. The sign kind of fits with our hypothesis. We can support the hypothesis in model 1. We are doing model 1 right now. So I hope you're following me in the interpretation of the results. Model fit works, we move forward. If it doesn't work, you stop and you go to the next one. R-square, I mean, it's low, but we let it go. No multicollinearity, we move forward. And the significance, it's correct. It's less than 0.1. And also the sign is what we expected, so we support. What happens if we pass the model fit, but if the significance is zero point 0.2, for example. That means that that variable is not significant, so we reject the hypothesis, right? It's different from when the significance of the model is not significant, because that means, boom, you cannot do anything. You just forget about it, you move forward. You cannot interpret. If you move forward with this, the R square is fine, no multicollinearity, but the significance is not correct, you can still interpret as rejection of the hypothesis, right? So you can reject. Or what happens if this is significant, but the sign is the opposite? Like if you expected it to be negative, but it's actually positive, you also reject. You also reject the hypothesis. You say like, it's not what we expected to happen. So I hope this is clear, but we can also discuss later on if you have any questions. Let's do the second model. The second model, we will keep open again the linear regression window. We will keep happiness as dependent. We will have our independent financial stress. And now we will include the general controls, gender, age, year, university, level, and Sweden. Select the six and move them here. And then just click OK. And now you have model 2. Model 2 is a model where we have 6 control variables. In this one, we will do the same checks. So first, the significance is significant. That's very good. So for group 1, we pass the first test. Second thing, the adjusted R square. So it's 5.3%. It's also low. I'm a bit surprised that even with the controls, we are low. But okay, we can let it go. Then the BIF test. Now it's actually very important because we have control variables, but the highest BIF is 1.27. So it's not an issue. We definitely not an issue. If there is something more than 4, we have an issue and we need to fix it. And if you remember the lecture, how we fix it is we remove one of the ones that are very high. Maybe the one with the highest BIF, we remove that one and let's see what happens. We remove it from the regression. Okay, so you remove it from here, but we don't have that issue, so we move forward. And the significance of our variable, that's the final thing to do, is still low, zero point 0, less than 0.001 with financial stress. And it's also negative, the sign of the standardized coefficient. So it's negative because this is negative and this is significant and the model works, there is no multicollinearity, the R square is fine, we can say we support the hypothesis in the second model. So 2 supports, right? We are moving forward. Let's do the final model. In your final model, keep the dependent variable, your independent, and all the controls, but now add also the 4 random variables that you added in the previous video. In the previous video, I think we used university satisfaction, locus of control, life balance, and relationships, quality of relationships as controls. So move those here, click, boom, they appear here, and then just click OK. And now we have a model 3 with a lot of variables. Maybe you also remember from the trustworthiness lecture that it's also important to have more controls because you want to show a robust model. That's why we are doing this. And we are also doing more than one model because we want to show robustness in the analysis. So we are trying to improve that by doing these 3 models and not rely on only one model. So let's do the same interpretation. Let's check the model fit. It's also less than 0.1, so that's good. We can move forward. Remember, if it's more than 0.1, we stop, and then that's it. The adjusted R square now is actually pretty good. It's 29%. That's quite good R square, so that's very good. Let's check the BIF for the multicollinearity. No issue at all. There is nothing wrong with it. The highest value is 1.42. No problem at all. And the final thing, let's check the significance is 0.009. It's below the zero point 0.1, so it's significant. And the sign is still negative. So in model 3, we also support the hypothesis, right? That's very good. Let's maybe do, I mean, like the final conclusion for happiness for this group 1, maybe I'm kind of doing the work for you, but for group 1, in model 1, you support everything works. The model fit, the R squared, multicollinearity, the significance and design, everything's correct, so you support. Model 2, the same story, you support. Model 3, the same story, you support. So the final conclusion is full support. If maybe there is another group, we can do one just for fun. Maybe let's try. I don't know. I will check with a different kind of group. So maybe one group with sustainable consumer behavior and sustainable consumer behavior with, I don't know which variable can be relevant there. Is it financial stress that was important? I guess financial stress was negatively associated with that. Let's do the first model. So it works. The R square is very low, but I mean, we can let it go. The significance, it's fine and it's negative. So I guess that group with sustainable consumer behavior and financial stress can support in model one. The next one, let's add the variables, the control variables of the six, and we click. It works. It's 0.002. It's fine. Improvement in the R square, financial stress. It's also significant and negative. So also support, no problem with multicollinearity. And the final model, and in here, I mean, we can vary it a lot because you will choose 4 random controls. I will choose, I don't know, biospheric values, bias, networking skills, and professional aspirations. Just 4 random controls, and I click OK. So it works. Okay, R square, no problem with multicollinearity. Significance, it's fine, and negative sign. So we also have full support. Well, these two groups have full support. It's a possibility that maybe you have something wrong. Let me see if I remember one that it's wrong. Maybe it can be with the SRI, maybe one of those. And I think global mindset is has an issue with networking skill, with professional aspirations, maybe. Okay, so I think this one is interesting. Significance, it's okay. 0.03, we move forward. The adjusted R square is very low, but it's okay. No multicollinearity, and the significance still okay. It's not super low. The p-value is 0.03, but it's still below 0.1, so it's significant. We can say it's okay. And the sign is positive. So professional aspirations has a positive relationship with global minds. I think that supports the hypothesis I imagine, and it also supports my findings from my paper. Then we add the control variables. Let's see what happens. Oh no, we have an issue in here. The significance is very low. It's 0.253. We cannot really do anything with this model. I'm sorry, but that's the conclusion. Model 2 doesn't work. With the controls, it doesn't work. So let's add now for model 3 uh, 4 random variables. Let's add networking skills, materialism, um, biospheric values, and what else can collectivism be? That's just 4 random things to it. And then we click OK. Well, in model 3, with more control variables, we improve the significance of the model. So this one we can interpret. So, okay, we move forward. The R square is 0.222. And no problem with multicollinearity, but oops, the significance is 0.855. There is no significance between professional aspirations and global mindset in this model. So this very interesting example. What is the final conclusion? In model 1 is support. In model 2, we cannot interpret because the model fit doesn't work. And in this model 3, this one with these 4 random that I picked up is not significant. So it's rejection. So you have one support, one rejection, and one that you cannot do anything. The final conclusion is inconclusive results because you have one and one. You have one support, one rejection, and one that you cannot interpret is inconclusive results. But you don't really have like a final, like one says yes, one says the other. So that is the finding. I will teach you how to theorize this finding. That can happen to you, but I think it's not common. I think most of you will have full support. or partial support, but I mean it can happen like this. So that's the end of this video where I'm teaching you the regression models. We have three models. The first one is just one variable, the next one with the six control, and the last one with four random variables that you choose. That's what you should do in this. The next video I will teach you how to move it to Excel, and that's it. With that, we finish.